Is that is that intended behavior of this thing? Really? Yes, so this is the vapcell S4 Plus 3 amp fast charger, apparently. Let's take a look at it. Let's take a good look at it. It's a charger I bought to charge my 18650s and other stuff, other kind of batteries that I need to charge. So I don't have a favorite brand. I don't know which one to get. I don't have other ones, like good ones. But I didn't want to pay a whole lot of money for one. I don't need it all the time. I just needed something that will give me internal resistance, possibly capacity testing, and charge a few different sizes of cell at the same time, and just do my flashlights and things like that. So I bought this because I went online and I was asking the internet, like, what's a good charger for this type of stuff? And this thing came up, and it was, $50. So I thought, yeah, it's about the right price point. It's not the cheapest AliExpress thing, and it's got a reasonable amount of features. So I thought, that'll do for me. So what I got was this thing, and it's 12 volts, 5 amps in. There's a USB output if you need to charge something with it, I suppose. There's an auto manual mode on it. It's got a big display with all kinds of graphics, mode and current, and you can set the charge current, and you can do discharging and capacity testing and storage charging and normal charging and the usual stuff. It does what I need it for. It seems to work. I've charged a few cells with it, and it's displaying things. So it's probably okay, I thought. But that weird behavior in the power up and power down modes, like when you turn it on and off, it's just weird. That felt strange to me. Like, it's the Plus, and they marked or advertised this thing as with the new software, improved, enhanced, whatever. Okay, it's a popular charger. They made a new version and ironed out all the kinks, so it's going to be great. And it's damn annoying, this thing. It is. It makes a horrible racket when you turn it on, and it works, I guess. But oh my lord, that's noisy. What's up with that? I mean, turn it off, the power supply goes off, screen goes off, and then it has a little panic attack, and then it goes down. Like, what is that? Well-engineered, normal products that you get don't do this. That is, I don't know what to say. Yeah, it works, I suppose. It's funny. This is the Plus version. You improved on it. What was the previous version like? I'm not quite sure. The user manual is similarly hilarious. There's like spelling errors and weird terminology. It's auto-translated from Chinese, I suppose, or something. But it didn't strike me that great. I paid 46 euros for this. It was the cheapest eBay seller I could find in Europe, somewhere in Germany. So it's, $50-ish product, as far as I know. I expected a reasonably good charger for that price from eBay, from the internet. If you buy this locally, it's probably going to be more. So I expected it to be a decent quality one, and it works. It does the job. So I don't want to bash it too much. It's doing the job. But I thought, well, it seems a bit weird, and I always like to take things apart. So let's take it apart. Don't turn it on, take it apart. We'll take it apart and see inside and see what gives. On the back side, you got the usual arrangement, 2 screws visible here and here, take them out, and then of course there's the 4 feet, the stick-on feet. You can pop them out with a screwdriver real easy. 6 screws, Phillips number 1, and it comes off, and the case comes apart nicely. So no problems there. It comes apart nicely, goes together nicely. There's no warranty void stickers or, you know, funny screw heads or any traps for you to open it. It just opens up easily, so it's fine, and it looks like that. I'll bring a closer look with a better camera angle soon, but the basic layout, you got the main chip, you got some probably comparators or op amps or something to measure the voltages, and you got your DC to DC converter stuff to individually handle the currents to all the cells, I hope. You got temperature measurements somewhere in there, I hope. You got some diode protection and whatnot, and there's a discharge function as well, so there's going to be like a MOSFET or something to drain the battery as well and take some of the heat. Maybe some of these big resistors, load resistors, might be used for discharging over there. And typical looking arrangement, layout. Nothing wrong with the layout immediately. I think there's nothing rattling about inside, anything like that. It looks fairly normal. The sliders for the batteries are a bit scratchy, not, a little fiddly, but they do the job. It's the usual thing. It's got the spring-loaded stuff, and various sizes of battery fit there. The spring is non-linear, so this is loose and it gets very stiff once you go out in the fully open. I would have appreciated a linear spring used here instead of a non-linear one, so that it would have about constant force throughout the whole travel instead of this job where it's very loose at the top and very tight at the bottom. That could be improved. You call it a plus. I would have put in a linear force spring in there if you can, but I don't know how much that's going to cost in manufacturing anyways. Yeah, I took a quick look at the board with a magnifier, and first impressions, it's dirty. So the board is dirty. There's all kinds of manufacturing dirt, grime, solder splashes all over the place, little balls of solder, dark spots in the big hand soldered connectors and things in flooded areas. So they used some kind of sputtery, maybe poor quality flux or something, and didn't do a very good job of cleaning the board. So manufacturing and soldering quality isn't the best. Some of the solder joints look kind of bad, to be honest. The components are reasonably well aligned. I haven't seen anything completely out. There's like a wonky capacitor somewhere that's a little bit tilted, but it's fine. Nothing too bad, but it looks, B-rate. It's not the kind of manufacturing I expect from a big Chinese factory in the 2020s. You can do better than this. So this is a cheap product. Obviously, it's coming from a cheap factory. It's not a big brand name item. I don't know the brand. Like I don't know anything about the reputation of these things, or vapcell, or who they are, what they do. I'm not really into these things that much. But it strikes me as a cheap and cheerful kind of thing. It works, but it's not perfect. I did take a quick look with a microscope, and I immediately spotted that this capacitor here, it's tiny, I know, can't see it very well, but this, I'll try to get some kind of view. So this little guy here, it's cracked, so it has a big crack on it, just right like a chip removed. I'll try to get a close-up shot of that guy, just to show you. So that, you know, it's not shorted, but it's definitely when the MLCC caps, so that when they crack, you know, they do short quite easily. So that could become a problem. So I think I'll take away the damaged component, see if it still works without it. If it does, it's just a filtering cap or something. I'll whack something there that's, you know, similar size or whatever. It's not a big issue, I think. But yeah, I don't want to leave a visibly cracked component inside. And then I'll clean the thing, because yeah, you got these solder splashes all over the place. So, you know, if something moves a bit, you know, could be a short, unintended thing. You can see little bits of just shiny piece, like there's a ball of solder on the board. Like this is the worst thing. It's not washed properly. It's not cleaned properly. So all these bits of solder loose in here. You know, you move around, you shake around, and you know, you can't really see it probably. There's a little ball of solder on my finger that just came off the board. You know, one of these moves and it just goes in between one of those legs or something and shorts something out. You know, can do whatever. And we do have high power lithium cells in here, so if that happens to short something that's directly connected to the cell, you know, you could have a bunch of amps flowing through it and, you know, make it pop. So yeah, I'll give it a clean, but I'll give it a good look first. I'll try to give you a close-up of the capacitor if I can, just to show you what it looks like, and maybe get a couple of close-ups of the board just to show the general state of things. I'll try to set up a better camera angle and take another shot of that momentarily. So yeah, this camera isn't the best. I really need more magnification, but maybe you can see a little bit in the bottom of the capacitor there. It's just shipped from underneath there, like this end of the capacitor is just, there's a chip. It's just broken in half a bit. So yeah, you can't really see it very well with this thing. I mean, trying to use a magnifying glass between the camera is, yeah, it's not great. Apart from that, the soldering, you know, it's not great, not terrible. Got some dark areas, some gunk. There was some resistors somewhere that I saw that were looking a bit off. Like there's a big flood of just chemical residue on the board. Looks like from the hand soldering there's a bunch of flux, and they kind of gave it a quick wash maybe and tried to clean it off a little bit and just didn't really dissolve it fully. It's not a problem as such, you know, there's probably no clean flux in anything, so it's not going to be terrible, but you know, it's not the production quality you see in good quality stuff. Of course, it's internal, and as long as the thing works, it's, you know, you're fine. And a little haze of solder balls, like all these little white specks you see on the board really are solder balls. And from these hand solder things, there's just sputterings all over the place. Between, like, you know, you probably don't see it very well, but it's, you know, near the pins there, like it's just sputtered and weird. It's not perfect. Yeah, and I saw some splashes somewhere between the legs as well, like almost touching. So yeah, lead-free stuff. It's not great always. But yeah, you know, it is what it is. It's a cheap product. I can appreciate that. Could be worse. Yeah, I'll give the board a clean, brush off all the balls, and do something about the cap. I think I'll just take it off now. And I'll power it back up, I'll put a battery in, and I'll just make some measurements. The most important thing, of course, is the voltage measurement accuracy in the battery charger, especially lithium. You want the accuracy to be there so that the voltage is showing is the correct one. If you overcharge lithiums, they will get destroyed quite quickly. And if you undercharge them, of course, well, you're not going to fully use the capacity. So yeah, I'll make some measurements with the trusty HP and see how close the voltage indication here is. And can I get a current measurement of the battery? I don't think I can easily. I mean, I'd have to bodge wires to the thing to get the current. I'll have to think about that. Oh, the silver thing there is probably the contact where the temp sensors go to, so they'd come here. Yeah, these are probably temp sensors. So it does individually probably measure the temperature of each cell in that spot, which is good. Yeah, I'll work on the board a bit and then I'll make some measurements. Oh right, wait, the other side. Almost forgot about the other side. Yeah, so of course the board, this is the underside we were looking at. Of course there's a top side to the board as well with components, so let's take a look. The board just lifts off. These tabs go through the slots, so they turn, so you just turn them sideways and the tabs just fall out. And then they go through the slots, so yeah, you just turn the tabs and pull the board out carefully. There's a ribbon cable here, so with one of these flex connectors, so you just pull the black tab forward to release the flex, and you just pull the flex out. Back there it's just the LCD board, nothing interesting, backlight wire, there's nothing interesting there. That's just a basic power board. Yeah, there you got your DC to DC converters, individual ones, just to control the battery separately. So it does have 4 individual charge channels. It's not just paralleling the cells with resistors or something stupid like that a cheap charger would do. So it's a decent 4-channel charger, I guess. Here's a few parts, look like MOSFETs, probably maybe regulators. These, I don't know if it's just me, but these parts look suspect. There's an F there, like a, is that a Fairchild logo or something it's supposed to be? I don't know, I just can't focus. They look like fake MOSFETs to me. Like all the world, like the printing or the lasering is kind of crappy, and the shiny legs and the shiny plastic. I don't know, but if I had to make a guess, I would say these are fake MOSFETs, if they intend to be like a brand name product. So they're probably a bit cloned or something, which, you know, there's nothing wrong with that really. I mean, just, you know, basic Chinese quality, they work. And you got a couple of parts there. There's also F branding. I mean, these are different. These have a printed lasered logo. They look more decent. Like the printing is a bit better. That's a different part. Yeah, I don't know. Yeah. The caps are going to be the usual suspect. Chong X, I think, is the cap brand. There, Chong. It's a typical Chinese brand. It's Not a hugely important application here, so they're probably fine. They do the job. These might be a bit fiddly to get back on. Yes, he put the spring through the thing and then, yeah, okay. Yeah. I suppose it comes apart and goes together. But yeah, that's what the top side looks like. It's a cleaner job on this side. I don't see anything strange. There's the little DC-DC converter just to get the 5 volts out from the USB, you know, 1 amp or whatever. Standard sort of job. Nothing fancy about that. And there's the switch for the auto manual mode. That's fine. But yeah, that's what it looks like. I'll have a go at the bottom of the board and put it back together and make some measurements. So yeah, I got the new part in. I didn't have this size of capacitor in the drawer right now. It's a wider one, but it's the same length, so I think it's going to be fine. It's tacked on. It looks a little dirty, but it's fine. It's connected. I measured it. The original one still measured 100 nanofards, so I think the capacitor, the original one, I mean, it seems to measure fine. It's not shorted. It's not open, so it works, but it looks cracked, and there was a weird spike left on the board when I removed it. So on the bottom pad there was like this spike that I felt it dragging the soldering iron, so when it came off, it almost looks or felt like there was a piece of this orange-brown capacitor material stuck to the board somehow, like there was an extra piece of that resin or whatever they use on the body of the capacitor. It was just like extra piece there floating from, you know, from manufacturing or something. So maybe, yeah, maybe it was something like that. I don't know, but it's fixed. So we have a non-cracked capacitor on the board. I gave it a clean. Generally, I just gave the board a quick wash. I gave it a brush with the ESD brush, and just to throw away all the solder balls and junk and splashes on it. I gave it some IPA spray and you know, the Kimtech wipe and a toothbrush, and then just cleaned it up a bit. I'll make another visual inspection just to make sure there isn't anything particularly nasty left in there from my cleaning efforts, but apart from that, yeah, I think I'll be ready to do the final inspection, put this thing back together, and make those measurements I've been talking about for a while now. Oh Lord, this thing is a pain to put back together again. Oh my Lord, it's not fun at all. Came apart easily enough. You just twist this thing around and it... Oh, and I realized it's still wrong. Oh, bloody hell. Yeah. These are on the underside normally, and then you just turn it sideways so the flap goes through and the thing comes apart. Putting it back together again, not so funny. I have to get this thing... Yeah, I have to get this thing in between there. I think I have to get it in between there somehow, and then have the spring engage the little latch thing. You know, I thought I could do it from the top side, but that's no good. Now it's leaving all this metal work on the top, and that's not where it's supposed to be. It's supposed to ride in the middle. Oh God, let me fight with this for 6.5 business days and nice. Ta-da, that's my test setup. So yeah, I've put a strip of nickel, just the battery terminal, you know, battery pack strip there to get a measurement on the positive contact. It's just a thin strip of nickel plating, or nickel strip between the actual contact of the unit and the battery, so I think there's not going to be any meaningful voltage loss there, and I'm just tacked on the negative side in the back, and my battery here is at 4.0585 volts right now. Another feature I noticed or remembered when I plugged it in, when you have a battery plugged in, this thing acts as a USB power bank. So in a pinch, you could put your 18650s or cells in here, and it's gonna give you an output from the USB, so you could charge your phone or something with it. It's not the best battery bank. I wouldn't travel with this, but if you got it anyways, you could use it both ways. So that's kind of neat. So let's make it scream by turning on the power again. Hey, it's not screaming. Okay. And it's starting to charge the battery. Okay. And it's showing 4.20 volts. And it's showing 24 degrees C, which is probably near enough correct. 90% charge on the cell. 4.20, and I'm reading 4.198 on old Hewlett Packard. So yeah, that's quite accurate. And it says it's putting, yeah, here's the charge current and charge. So it's putting 1280 milliamps into the cell. 4.200 volts now on the cell. The voltage is climbing, so that last digit there seems to be accurate for the first channel. For a full cell, I could see how far this charger will push the battery, but 4.20 at the moment seems to be where it's limiting. The voltage is creeping a little bit. 4.202 now, and the battery is filling up. So yeah, I think that's in spec as far as I can tell. I wonder if I heat up the pad a little bit and change channels, if I will get a different temperature measurement there, or is it just you know, saw some thermal compound on the other side, so I'm presuming there is a proper thermal element in here. 4.205 volts now there. Let's remove the battery and put it on channel 3 and see what that gives us. Yoink, and put that there. Put it on there. Channel 3, charge, auto. Shove the negative in somewhere precariously. Attach on the positive. 25 degrees again. I warmed up the plate a little bit, but I'm not sure if I did it enough to affect things properly. I might want to test the temperature thing separately. There's probably a protection and alarm function there, so that's kind of important with batteries. 4.212 here. So channel 3 is slightly higher. It's putting 800 milliamps into the cell. I'm reading 4.213. So it's 0.01 volts higher on this channel than the other one. Is it affected by the pressure? No. Okay, yeah, it goes down a little bit if I squeeze the battery in a bit, then the voltage goes down to 4.20 exactly. So the contact strength has an effect on the voltage drop, and of course it's, you know, it's measuring the voltage on the board and not in the battery. So if you do have a poor contact, it'll affect things a little bit. But yeah, 4.21, it's not far off. That's reasonably accurate. So yeah, I'd say the voltage measurement is good enough for what I expect this thing to be on channel 3. Let's go and measure channel 2. I guess I can use the same ground everywhere. Well, let's tack there. It's charging 4.10, 4.200, 4.20. Yeah, that's right on the money. So channel 2 is fine. No problems there. And I'll just awkwardly twiddle this connection to the last one. So channel 4 charging. And I'm having 4.20 there and 4.2015, 4.202. Yeah, it's very, very close on all the channels. So the voltage measurements are fine on this unit. I'm happy with that. How accurate the current flow is, difficult to say. I'd have to bodge a connection. Somehow a reliable connection. These things are not easy to interface with. I'd have to do it internally. I'm not going to bother trying to measure the current sensing accuracy. It's just measuring things anyways. The voltage is ultimately what decides how the cell is charged, so that's fine. You do have a bunch of modes on the mode button, so you can do like something, I don't know. Actually it's in auto right now, so you can, it doesn't do much. If you go to manual, I think then you can do like charge and discharge and store and all kinds of things. I don't know, I don't remember the manual. I haven't really done too much with it. You know, mostly I just charge my cells. I put it in auto, stick the cell in, check the internal resistance measurement. I've got 89 milliohms with a different device, measuring device on here. This is saying 73. You know, that's rather fine. It's close enough. It's going to separate the real bad batteries from the real good ones. Your measurement accuracy, absolute accuracy is going to be, you know, something. Okay, I'm getting 43 without the strip. So the strip was affecting the reading. 89, 43, that's quite a big difference. Twice the resistance this guy is showing, so I don't know which one is closer, but of course, you know, if you use the same device all the time and your battery's in here right, at least you'll be able to say, you know, which ones are good and which ones are bad relative to each other. You know, that's you'll be able to spot high current batteries from high capacity batteries and that sort of thing, I presume. Let's see how to change 48 milliohms on channel 3 for the same guy, and then let's see what channel 2 is going to do. Measuring, and you get 45 milliohms. So at least the channels are giving similar readings. What if I squeeze this up? 42. Yeah, so, you know, at least the channels agree with each other, so that's probably fine. Verdict. Vapcell S4 Plus fast charger. Would I buy one again at 46, 8 euros, whatever I paid? It works. I don't know. I mean, if this broke next week, I wouldn't buy another one like this, just because I would expect that one to break as well, because the build quality is not that great. If you want a really good high quality charger, no. If you just want a cheap thing you can plop in your batteries and go, yes, this will do that. But the manufacturing quality issues again, if you have all those blobs of solder inside, all the junk inside, do you really want to put 4 18650s here and leave the room knowing that you have all kinds of loose bits of metal in the box? No, I don't think so. So I can't really recommend this thing, although, you know, yeah, the power supply that comes with it, so there's a 12 volt input, so you get a 12 volt charger, AC adapter. It's the usual chip, very lightweight thing. You've got an LED. At least you see it's connected, powered, you know, it's fine. Made in China, of course. Output 12 volts, 5 amps. Yeah, it's the standard stuff, you know. It's not great. I'm not going to open this up because it's ultrasonic welded. And, you know, it's just going to be one of those things. There's nothing exposed really here. So if this loses isolation and it's just pushing mains through, you're not going to get electrocuted by this very easily because, you know, the thing is insulated. So if this fails in a spectacular way, it's not a huge issue, I think. So yeah, I'm not too bothered about using this, although it is a standard-ish barrel connector on the end. So another option would be to just take one of these leads and plug it into my lab power supply for 12 volts or whatever source, reliable source you have, and just plug it in there. It's probably better than using this really cheap charger, you know, overall. But yeah, it doesn't really matter that much. So yeah, it works. I'll use it. When it fails, I'll get another brand. I'll tear that apart, see how it's done, and all that. There's a QR code if somebody is interested in doing, I don't know if that, what is that? Is that like a authenticity thing or something that you can verify that it's an authentic product? Maybe, I don't know. Yeah. Do you know vapcell? Do you know anything about these things? What do you think? Is this a good one or a bad one? Or it's a scam or a good, high quality, accurate thing? And battery chargers just by nature are not, you know, high quality items that people would spend a lot of money on. Most of the time they just get the job done. What do you think? Put it down below. No, not that anybody's going to see this video, but, you know, if you have an opinion, let's hear it. That's all I have to say about this at the moment. I'll keep on using it. See you later.